This conference will now be recorded.
Good afternoon, students. Wait for a few minutes. Some of the students have to be joined here. Okay, students, let them to join the class. So in today's class, we are going to discuss about mathematical formulation for hydrothermal scheduling. So in second unit, we have two parts. One first part is hydrothermal scheduling. Second part is speed governing model. But in the first part, you may get surely this question. So I will show you previous question papers. Then you will get clarity on this whether this question is important or not. See the previous year question papers. I'm showing you. See, from second unit, we have two parts. One part is belongs to that hydrothermal scheduling. Another part is speed governing system. So in that, see here, derive the coordination equation for optimal scheduling of hydrothermal interconnector plants. So we have to formulate that how the scheduling will be happening, how we can make the scheduling among these two hydro and thermal connection. And here there are three parameters are involved. I already told you that what are the three parameters means inflow, discharge, and storage. And we have to make the formulation by using these three parameters. Then we have to coordinate that how we can form the scheduling among these two plants. So this is the direct question for 10 marks. Now I will show you another paper. So this is another question paper. Here also they asked explain about solution of pumped storage hydroscheduling with lambda gamma iteration method. So we are going to derive the derivation. It is in the form of iteration method. So why it is called as iteration method means here also we have to calculate that lambda value for different values for making that power balanced equation is a balanced condition. So this is also direct 10 marks questions. And we'll see the one more question paper. See here also the given there is a third question. explain decomposition technique for hydrothermal scheduling. So generally, the scheduling process happening in the hydrothermal scheduling is two types. One is long-term scheduling and second one is short-term scheduling. If they will ask, especially by mention these terms, by explain about long-term scheduling or explain about short-term scheduling, you can write. But here explain about decomposition technique means, so it is nothing but it is a long-term scheduling. So we have to take the different parameters with respect to the year wise. So the long-term scheduling is the under name is decomposition technique of hydrothermal scheduling. So I think you get clarity on this question, how much of importance it is. So please listen carefully while we discussing that. So it is a simple, very simple, but you have to remember that 2-3 equations. So no problem. So you can easily the equation should be similar to that what we discussed in the first unit. So now let me move on the topic, that is mathematical formulation for hydrothermal scheduling. Right. So this is the most important question from the second unit on part A. So don't neglect this question. Right. So what are the parameters? What are the constraints we are going to consider while mathematical formulation of hydrothermal power plant? See, generally, so if you take that separate plants, that is hydro and thermal. So if you take the thermal power plant, the scheduling process is very difficult. Why? Because we should have to consider that what is the fuel cost, what is the running cost, what is the maintenance cost. We have to consider all costs in thermal unit. But in the case of hydro power plant alone, while scheduling the process, it is very easy. Why? Because the cost of the fuel is completely zero. But in that there is no problem while scheduling in the hydro power plant. But in the case of hydrothermal power plant, these are predominantly hydro scheduling, may be done by scheduling the system to produce that minimum cost. See, well, compared to that individual plans, the combination of two different plans with respect to the cost oriented and running maintenance oriented, and the scheduling process is very difficult. And how we, but we have to make the scheduling to reduce the cost, right? So there are certain procedures we are going to do that for reducing the cost of the operation. Now the same thing we are going to schedule that when we are using the both combination of hydro and thermal scheduling by using different constraints with respect to that economical cost. Right. So here we are going to the scheduling in the sense, these are the two types. One is long term scheduling and short term scheduling. A long term scheduling is scheduled for 1 month, a year, and short term is for 1 day, 1 week, 1 month. So these are the two types of scheduling. Now while scheduling this hydrothermal plant, it should be depends on that different constraints. So it requires different constraints that was shown here. One is, the first one is the storage of hydro reservoir at the beginning and ending of the period are satisfied. So every reservoir has its maximum capacity, right? So that capacity decides that how much of generation should be generated. సపోజ్ ఒక హైడ్రో పవర్ ప్లాంట్ కి ఎన్ని ఫీడ్స్ అని ఒక కెపాసిటీ ఉంటుంది, దాని తగ్గట్టు కెపాసిటీ తగ్గట్టు అది జనరేట్ చేస్తుంది, కానీ ఎక్కువ తక్కువ చేయదు. సో అది ఎలా అది దానికోసమని మనకు వీ హ్యావ్ టు నో దట్ how much of water inflow to the reservoir and how much of water is discharged from the reservoir. Based on that we can generate the power. We should have to know these two parameters. These are the two requirements while scheduling the hydrothermal power plant. Next one is water inflow to the reservoir. So water inflow reservoir, suppose if the reservoir if the reservoir's inflow is 1000 cusecs, but out of 1000 cusecs, there are certain percentage water should be used to the irrigation purpose. After that, remaining water we can use for generating. So that has to be considered. And that also it should be depends on the what is the load demand. Suppose if the load demand is 50 megawatts and the capacity of the reservoir is 1000 cusecs. Now the 50 megawatts power should be needed by only 700 cusecs, and remaining 300 cusecs they have to use for irrigation purposes. Why? Because if you are using the 800 cusecs, it is a waste of water. So that has to be scheduling like that. For example, if they need 40 megawatts, it's need only 600 cusecs, and remaining 400 cusecs they can use for irrigation. So these are the certain parameters they have to consider that while scheduling that hydrothermal power plant. So now two constraints are over. Now we'll see that next one. Right. So after these two constraints, we are going to derive the mathematical formulation in two methods. So you can write any one of the method among these two, right? So the problem is to determine that the two parameters. One is Q of T. It means that how much of water is flow from the dam, that much of power has to be generated, and it is completely and this parameter is minimized that what is the cost of the total generation. So the cost is given by CT is equals to integration of 0 t. So integration 0 to why we are using the integration here means we know that particular interval. So if it is 6 months means we have to calculate that 0 to 6 at first month, second month, third month, fourth month, 6 month like that. So I already told you that integration is useful for where we have to use that starting and ending point. In between that we are going to use that integration, right? So that's why we are giving the intervals with respect to the starting and ending time. That's why we are using the integration here. And C of PGT into T of DT. So here we are going to find that every plant generation, that is as well a head of power plant plus thermal power plant. Then only we can clarity on that what is the total cost among the with respect to the two generating stations. Now in this we have to formulate that three equations. When the three equations are satisfied, then our scheduling is perfect manner. Now let me see that what are the three equations we are going to formulate for scheduling. So this is the method one. So it has the two methods. You can use any method, whatever is convenient. The first one is meeting the load demand. So meeting the load demand, how it is possible means when the generation is equals to demand plus losses. When it obeys this equation, then it need that meeting the load demand. So this is the energy balanced equation given by based on that how much of power is generating, how much of power is requiring, and how much of power is lost. Now when these all powers are satisfied and it becomes zero, then the power scheduling is done very good manner. So that has to be considered here, and the time interval is 0 to t. So the time interval is taken as a main constant for three equations. So if you are scheduling this in for 6 months, you have to take that 0 to 6. If you are scheduling for 12 months, you have to take for 0 to 12. Like that, you have to consider that. So note down this equation. I reference the equation numbers. So it is important for upcoming equations. Why we have to substitute so and so equations, right? So just note down this equation and reference the equation numbers. So this is the first constraint. We have to meet that load demand. So constraints is nothing but a what is the requirement. Next one is water availability. So for scheduling purpose, it's need water availability. Without water, we can't able to schedule, right? So the second constraint is water availability. Here we are considering that three parameters. One is inflow, another one is outflow, that is discharge, and x of t, x of 0 is storage at final stage, storage at insert stage. Okay. So these are the four parameters which are belongs to that completely hydro plant. So here capital J of T is a water inflow, Q of T is a water discharge, and X of T is a water storage, and T comma 0. So T0 is nothing but the water storage capacity, the water in the storage at starting end and ending end time is during the interval. So if we are taking the intervals 0 to 2, right? So this is the starting and it is the ending time. So we have to make that what is the storage of water available at starting end and ending end. So this constraints. So this is also a balanced equation, and this constraints to be made as a 0. Then only the water availability constraints makes that perfect in the scheduling process. So note on this equation and represent it is equation 3. So now we'll go for third one. So third one is nothing but the hydro power generation is a function of water storage and water discharge. So already we know that. So that's why we are functioning that. It means that the amount of power generation from the hydro power plant, it is completely depends on that what is the storage. So here there is no bother about inflow. Why? Because we are using the storage capacity, so we can use it, we can use this method for pumped hydro power plant also. So that's why the power generation is a function of two parameters. One is water storage and water discharge. Now the optimization interval, that is T, is subdivided into m subintervals. Suppose so I already told you that here we are taking the scheduling for 6 months, so we can't able to use that directly 0 to 6. So we have to divide these intervals to sub-intervals like 1 month, 2 months, 3 months, 4 months, like that. So these are the called sub-intervals, and we have to make that. So at first month, how much of cost is happen? At second month, how much of cost is happen? Or third month, fourth month, fifth month. So then only you can know that at which month it requires the most cost is happen. So so it means that in 6 months the weather duration is not constant. So sometimes it may be a rainy season, sometimes it is summer season, sometimes load may be changed with respect to the different seasonal conditions. So that's why we have to separate that starting, that is total time intervals, to the sub intervals. Then only we can know, we can get the idea at what month how much of power is required and what are the external constraints are involving. So we can get idea on this. So that's why the total time is subdivided into m subintervals. That equation is given by this equation number 5. So this is the equation only for hydro power plant and sensor. This parameters 1 to 3 1 to 3 up to m, right? And this is the term is belongs to that thermal power plant. Sorry, here left side it is H. And after from this equation, we have to assume that all the variables are in the sense of water discharge, water availability, water inflow, and water storage. We have to fix value. Then only we can easily find out this type of mathematical formulations. So these three constraints are used for the mathematical formulation for hydrothermal scheduling. So next we go for second method. In second method also we go for same methods, but the equations representation is different when compared to this five equations. So up to now we got five equations, right? So in the second method we will see that different equations. So now we'll go for second method. See, this is the method 2. So what we discussed in method 1, the same constraints here also we are involving that. But the difference is based on the notation. So for example, actually two methods are the same. కానీ ఈక్వేషన్ పారామీటర్ రిప్రజెంటేషన్ అనేది డిఫరెంట్ గా ఉంటుంది. సో సపోజ్ కొంతమంది ఒక పారామీటర్ అనేది కొంతమంది ఎక్స్ అనుకుంటే కొంతమంది ఏ అనుకుంటారు. సో సేమ్ థింగ్ వీఆర్ డిస్కసింగ్ ద సేమ్ ఈక్వేషన్స్, but the representation is different. That's why I'm saying that it is method 1 and method 2, and both are same. So you can write anyone in your exam. The first one is as well same power balance equation. In this method, the representation of power balance equation like this. So PM that is so we are dividing the sub intervals, right? So we have to calculate that interval. So for first month, second month, third month, we have to calculate like this. So here PMGT is the power generation from the thermal power plant. This is hydro power generation, losses and demand. If the all powers are equating to the zero, then the scheduling process is in good manner. And while calculating the power losses, we have to use this power loss transmission loss equation. But in the case of method 1, there is a different approach to calculating the power loss transmission loss equation, transmission loss value. So in first method, the losses can be calculated based on that statistical analysis. That is, what is the by taking the previous data and comparing that everyday calculations, then they can identify that how much of losses there is occurring in the transmission line. But in the case of second method, they are without any comparison, they are going to directly calculating with respect by using this transmission loss formula. So why? Because this method too they are using for the computational purposes. It means that everything should be done by the computer, so that it is easy to convenient but scheduling the process. So this is the equation 1. Next equation 2 is water continuity equation, or it is also known as water storage equation. See here the same equation, the same parameters are involving in this equation, but the different is representation. And in this case, in this method, the water continuity equation is keep on going to be changing with respect to the consecutive months. Consecutive months means suppose if they are calculating that fifth month means, so they can use that fourth month equation for calculating the fifth month. So here mentioned here, suppose here m is the fifth month, m is a 5. Then if you want to calculate this value, they are using for fourth month calculations. and these two parameters are constant. I already told you that inflow and outflow storage the inflow and discharge should be constant, and the only variation is this one. So reference, this is equation 7, and the equation 7 can be represented in the form of like this. So this is the changes in the, that is the previous what are the changes between the previous month and this month. So they are indicating that delta t. So delta t in the sense that is total time period. And the equation 7 we can represent it the same as equation 8. Just note down this equation 7 and 8. Have you all noted this? Equation number 7 and 8. Next, we go for third equation. This one. So this is the hydro generation with respect to the subintervals, and this is the final equation with respect to the hydro power plant with 2 months data by using the 2 months data. And this equation is completely oriented with respect to the hydro power plant alone. So why we are using only hydro power plant means the fuel we are using in the hydro power plant, it is not constant available. So based on the rains and based on the floods, the water availability will be available. So that's why based on the water availability we have to be scheduled that, and the scheduling of hydro power plant is not constant. But in the case of thermal power plant, it is constant for entire throughout the year. But in the case of hydro power plant, the scheduling of the throughout year is not constant. Why? Because the water availability in the throughout year is not constant. It is completely depends on the weather conditions. So that's why the scheduling is mainly when scheduling the power generation with respect to the long term, the mainly concentration on hydro power plant, hydro power plant instead of thermal power plant. So how to check means based on water sense they can schedule. If the water is available less means they will give the more capacity they will generate the more capacity by the thermal power plant. If the water availability is more, so the power generation by the hydro power plant is more than the thermal power. So based on the water availability, so the schedule will be occur. So these are the two methods of mathematical formulation for hydrothermal scheduling. So up to now, we found that 9 equations. Now, by using these 9 equations, that is 3 equations, how we can make that different parameters. So actually, mathematical for cheyalante, we have to use the Lagrange multiplier, right? So what we did in the last that is first unit, the same thing here also we have to use the Lagrange multiplier. Then we have to use for different conditions. Then we can find that unknown value. right? So the equation which are using to find that unknown values, that equation is called as Lagrange equation. So here, what are, so for we derive the three mathematical equations, and the three mathematical equations require that different lambda value. So that's why I mentioned here lambda 1, lambda 2, lambda 3. Now these parameters we have to find by using that what we formed the three equations. Now if you look back this equation 12, this is the representation of Lagrange multiplier, and this term is total cost with respect to the power generation stations, and lambda 1 m. So this is the constraint with respect to that energy balanced equation, and lambda 2 with respect to the water storage capacity, and lambda 3 it is a hydro scheduling. So for measuring these three parameters, that is lambda 1, lambda 2, lambda 3, we have to use that Lagrange multiplier, and in Lagrange multiplier we have to substitute that the three equations 6, 8, 9. So if you substitute this equation, it will be look like this one. So note down this equation. By using this equation, we can find that lambda 1, lambda 2, lambda 3. Let me see how we can find. So just note down this equation. So now we go for what are the different conditions to find out that these three constants. Right. So if you want to find that lambda value, lambda 1, lambda 2, lambda 3, what we have to do means we have to differentiate Lagrange multiplier with respect to that four parameters. That four parameters are, one is with, we have to differentiate with respect to that power generation by the thermal power plant, and second one is we have to differentiate Lagrange equation by using that power generation by the hydropower plant, and by the that is a number of intervals and water discharge. By using these three conditions, we can calculate that lambda 1, lambda 2, lambda 3. See, if you compare this equation with respect to 12, when the equation 12 is differentiated with respect to that generation power with respect by the thermal power plant, you will get like this. This is the equation you can get. So note down these four equations and compare that with respect to the 12th equation. Then only you can understand that. Now we'll see that among these four equations, by how we can find that lambda 1, lambda 2, lambda 3, and it means that for finding the lambda 1, which equation we have to use, for finding the lambda 2, which equation we have to use, for finding the lambda 3, which equation we have to use. So I will tell you, I will show you that. See here, the variables, that is lambda 1 and lambda 2, lambda 3, from lambda, the lambda 1 can be obtained from the equation 3. How it will be, let's see here. See here, this is the equation 13. In the 13, there is only that is lambda 1 is only available. So there is no lambda 2, lambda 3. So you can easily find out that lambda 1 from equation 13. And similarly, if you find it lambda 1, then you can substitute here, then you can calculate the lambda 3 value. So it shows that the lambda 3 can be obtained from the 14th equation. Next one is lambda 2. So lambda 2 equation, lambda 2 value can be obtained by using the 16th equation. So these three equations can be used for finding that lambda 1, lambda 2, and lambda 3. So this is called as a solution technique for mathematical. So after finding that our formulations, we have to check that we have to find these three parameters. Now we see that algorithm. So algorithm, it means, oh, this is the iteration process. So we have to check that until the balanced condition is satisfied. So that is the thing. That's why it is also called as iteration method. Now, what are the different steps involving in the solution method? The first one is assume all initial set of all independent variables for all subintervals except the first. So we have to already told that the independent variables we have to keep in constantly except the first iteration. So after first iteration, remaining of all iterations we have to use the same parameters. Next, obtain the values of dependent variables, that is the storage, power generation from the hydropower plant, power generation from thermal power plant, and discharge. By using that 8th equation, 9th, 2, and 10th. So by using these three equations, we can calculate this value with respect to the m is equals to m is equals not equals to 1 and 2, 3, 4, and so on m intervals or t intervals. And after found these values, if you substitute these four equations in 12, 13, that is 13, 14, 15, then you can obtain that these three constants, lambda 1, lambda 2, lambda 3. And this value should be used for that when m is equal to 2. So from second iteration onwards, we have to update these values, lambda 1, lambda 2, lambda 3. At initially, we have to assume the lambda value. After finding this, by using this value, we can calculate these four parameters. Now, by using these four parameters, again we have to update the lambda value that was obtained by here. And this lambda we have to use for second iteration. Next. So in fourth algorithm, what we have to do means, after finding that lambda 1, lambda 2, lambda 3, then we have to check that balanced conditions. If it is not reached, if it is not equal to 0, see here. If they all equals to 0, then within a specified accuracy, if the optimum is reached. So ఎప్పుడైతే మనకు 0 వస్తుందో, then it is reaches the optimum condition. If it is not continuous, if it is not continue the procedure from step 5, so it means that again we have to use that different new values. See, that is the water discharge value. So here the only this value should be updated, that is new value. By using the old value, we can update that new value, and we have to use that again same procedure Then we have to calculate lambda 1, lambda 2, lambda 3. By using this all constants, we have to check that whether the three equations are balanced. So three equations balanced means equation ni man add cheste zero రావాలి. So zero వస్తేనే then it will reach the optimum condition. So once again I'm telling that this is the most important question from the second unit. So don't be neglected. So just already I sent you material, right? Just practice it now. So then only you can understand. So it is simple question. Simple question. You can easily attempt that question and you can easily get the 10 marks exactly for this question. Why I'm saying is when compared to the part B, your part is simple. So only 2-3 questions are there. But in the case of part B, so it is a huge derivation part. So better you choose that this prepare this question, then only you can attempt the question from the second unit. Right. This is about today's class, students. Do you have any doubts on this? And in this topic, you may get what is how will explain about what is the optimum scheduling of hydrothermal power station. So you may get this type of questions. Okay. So I am already sent the PPT also, so you can check the PPTs and you can see from there. So while reading this all questions, first of all you have to thorough with previous question papers. Then only you can get idea. So what type of questions they will ask, or how the questions will be asked. ఎందుకంటే ఫస్ట్ మీరు క్వశ్చన్ అండర్స్టాండ్ చేసుకోవాలి. ఎందుకు ఒకవేళ మీరు చేసుకోవాలంటే వాడు ఒక క్వశ్చన్ అయితే మీరు ఒక క్వశ్చన్ రాస్తారు. ఓకేనా? ఫస్ట్ యూ షుడ్ అండర్స్టాండ్ దట్ వాట్ దే ఆర్ ఆస్కింగ్. సో అండ్ వాట్ యూ హ్యావ్ టు రైట్ విత్ రెస్పెక్ట్ టు దట్ క్వశ్చన్. దట్ షుడ్ యూ హ్యావ్ టు నో. So how many only 2 members are didn't write the exam. Who are they? So strip test one is the రాయలేదు ఎవరు చెప్పండి ఒకసారి. Who are not written that first exam, the strip test one. Who are not? Right. Okay, students. I'm going to end this class now.